Bonjour Jacques Dangermond, merci de nous recevoir ici à Redlands en Californie, au siège d'Esri. Alors Esri est une société que vous avez fondée avec votre épouse Laura en 1969 et qui est maintenant un leader mondial en matière de systèmes d'information géographique, bien devant Intergraph, Bentley et Autodesk. Alors est-ce que vous pouvez nous expliquer tout simplement pourquoi, quels sont les points clés qui font la réussite d'Esri?
First, I don't take our success for granted. You might think of us as successful, but I think of us as it's a process, not an event. And so part of our secret for success is that we don't treat it as being successful. We treat it as being in service to our users. So that's our whole philosophy, is we set up ESRI to be in service to our customers, and we listen to them carefully, and we try to engineer products that really respond to what they need and want. So the relationship with our customers is one ingredient. A second ingredient is that we're a private company, and that means that we can invest all of our earnings back into the engineering cycles that make our software. So rather than, say, a 10% or 12% of investment of our gross revenues into development, we spend between 23 and 24%. So we doubly spend. But that doesn't explain everything. The third one is strong engineering talent. So you can spend a lot of money and not have good products, but our people here are some of the greatest software engineers in the world. And we treat them that way and we support them that way. They're very creative. They're not gods, but they understand software engineering and they understand geography and mapping. So for these 4 decades, we have invested in them and invested in the process, which generates good products. And even that doesn't explain our success entirely. A fourth component is having strong values. And those are values that are focused on the end users, but also values of good business relationships, good friendships, good community within our own company and within our partners, our international distributors like Esri France, for example. And over years and years and years, keeping that friendship network together is very important. And then finally, we have a passion for what we do. We think it matters. And I don't know if that's really the reason for our success, but we enjoy it. Very few people actually get a chance to do what they really want to do, and they are doing what they really get excited about. I'm one of those people that have that fortunate blessing. And my colleagues around me, the people who I like to get to work with me, have that same sense of being. We like our work, and we think our work is important. So empowering our customers is our main mission. So by being a private company, we're not interested in the stockholders, we're interested in our users, who in a way, metaphorically, are our stockholders. They get us excited.
Et malgré tout, vous avez un environnement de travail ici à Redlands qui est tout à fait agréable pour vos salariés, effectivement, que vous disiez, que vous évoquiez. Alors, parlons un petit peu maintenant de l'avenir des SIG, et sachant que les SIG de bureau, notamment les desktops, ils sont de plus en plus confrontés à l'avancée du SaaS, du cloud. Comment est-ce que vous voyez en fait cette avancée?
A lot of our technology is client-server, desktop technology, strong server technology. We have over 1 million desktops implemented and over 100,000 servers. Those are what we'd really call enterprise customers. And the desktop deals with computationally intensive problems. That's what it's designed to do, personal processing and computationally intensive problem solving. I don't see that going away. We have, in the last year, invested enormously into a cloud solution, a SaaS solution called ArcGIS Online. And that complements, doesn't replace in all cases, the desktop and the server technology. Yes, there's some overlap, but the way that we're implementing this is one complete system. It's kind of like the marketing words that Microsoft used of software and services combined. This truly is software and services, so users who license our desktop have services that come with it from the cloud. And those services allow them to author on the desktop and create map services in the cloud that can be accessed by anyone. through mobile devices or through browsers, or they can embed their maps inside of blogs or inside of websites or email their maps around. So this geospatial content management system, ArcGIS Online, is just part of their whole ecosystem. And yes, there'll be users who simply just use it, like enterprise mapping customers. There isn't really competition in this space. There's certainly competition in the desktop space. There's certainly some level of competition in web mapping services, not complete GIS servers, but there's some competition there. In this new space, the cloud space, it's a wide open market, and it goes beyond the traditional geospatial-centric workflows of engineering and planning and management and forest management and water and urban and so on. It means that I can bring mapping into everything. So we are jointly releasing with Microsoft a wonderful new technology that puts maps in Office. So people that have Excel can put mapping inside their spreadsheets, or if they have SharePoint customers can use GIS and mapping across the enterprise. This is going to blow open the market in new ways. Will that damage the desktop world? I don't think so. Our desktop business is growing and very alive, and this last release that we just made demonstrates the enormous growth potential that platform still has. And our plans for what's going to happen in 2 years with our next generation of desktop continues to make it easier and faster. And so I just don't see desktop as a intelligent client going away. Yes, we're adding the iPad. We've added the iPad, the Android devices, the iPhone, all of these other mobile devices. Things are definitely moving in that space. SaaS and mobile devices are definitely a whole new ecosystem, but that doesn't replace the need to have geospatial professionals who actually create, manage, do high-end analytics using the desktop.
Et c'est en vous appuyant sur ces technologies cloud que vous serez capable de proposer un système d'information géographique 3D.
3D GIS began with our version 10. We added the 3D data model into 10. That was almost 2 years ago. With 10.1, the release that's coming out in June, we added many tools that analyze 3D data models in a GIS environment. This has been tricky because other 3D approaches like BIM models, like Rivet or its competitors, are really wonderful technologies for document management and engineering and even design, but they don't scale to handle hundreds of thousands of buildings. What we've been engineering in ArcGIS has been building a complete 3D data model both above the ground and also under the ground for things like pipes and infrastructure. That's now complete, and it's in our traditional desktop and server environment, so I can author one of these 3D virtual cities, for example, in the desktop, serve it out on the server. In the cloud environment, you can also do 3D services. So the cloud offers the platform for dissemination of 3D information. And we are currently working on visualization tools in browsers that can encapsulate a 3D object scene and be able to spin it around and view it as a plug-in to a browser. This is new technology. So it's on a scaled out server environment where you can handle a whole city at one time, but through very thin client access. We're also developing even thicker clients that can run in the desktop for the same thing.
D'accord. Je souhaite maintenant évoquer un point qui peut être polémique chez Esri, c'est l'utilisation de l'open source. Est-ce que, déjà, qu'en pensez-vous de cette technologie? Et est-ce qu'Esri s'appuie déjà à l'heure actuelle sur l'open source pour développer ses propres solutions et par exemple le Proj 4?
Well, open source as a general philosophy for us is a good world. We open source some of our tools, and we're going to be open sourcing more of them at the app level by providing open APIs and also our app level of software is also all going open source. So this is kindling or starting a fire in the development community where they're layering open source applications on top of our foundation. Also, we believe and strongly support open source as an environment for innovation. We include some open source components from that world inside of ArcGIS. For example, the Python scripting environment, our raster engine, some of our geostats technology is all open sourced, and that's helped us quite a bit. Some people see proprietary system versus open source as competition and war. I don't view it that way. It's an environment for innovation, and so we're working very hard at a heterogeneous environment where open source can be mixed with proprietary platforms like our own to build solutions. And we're doing that with developers, with some of the open source foundation organizations. So it's more like IDM in the sense that we're trying to embrace it as an environment. Having said that, the open source development environment is a different engineering model than what we use for our core. So there's got to be lines drawn between that. And I think we're approaching that in a sensible way. But we're very strongly supportive of the open source community. The open source community also has a different business model. So rather than purchasing software and then going into a technical support agreement, you purchase services to do the actual implementation. So it's a different model. Once end users understand the distinction between these models, they can actually better engineer real working solutions that they have 7x24 support on. So we're inching along in that environment.
Parlons maintenant un petit peu de l'évolution de votre marché. En France, à l'heure actuelle, esri est de plus en plus tourné vers le monde du BTP, de la construction. Déjà, que pensez-vous en fait? Que représente pour vous ce monde de la construction? Est-ce que vous pensez, comme il est peut-être envisagé en France, qu'un jour, les bases de données SIG viennent se mettre au-dessus de ce qui est utilisé à travers le BIM, par exemple, et l'utilisation des IFC, qui sont certes des données interopérables, mais limitées à un seul bâtiment? Est-ce que le SIG peut être un jour la méga base de données qui supplante tout ça?
Well, first, there's several things I want to say about this, about your question. The first is there are multiple 3D data models. There's BIM data models. There's a sort of simple SketchUp kind of model that Google and now I guess Trimble have pioneered. There's our own, we call it 3D shape files, or sometimes called multi-patch files that fit into the fabric of large GIS. There's also multiple vendors who are supporting different kinds of BIM models, and then there's the whole IFCs, which are the standards-based BIM model. Each of those serves a different role. Fast visualization on one case, but not very good document management. In the case of BIM models, very good document management, but not very good performance. In the Google's case, it's very fast display performance, but not very much intelligence. So the way I see this evolving is through ETL, extract, transform, load, interoperability, rather than one model like the IFCs forcing everybody to go to one model. I believe that there'll be heterogeneous models. And given the increase in performance and computational reconfiguration of the different data models, we'll see very fast movement back and forth between these different models. So people that want to do GIS things like 3D analytics or 3D visualization in very large volumes will choose ArcGIS as a platform. Architects may choose one of the other technologies to be able to do design or engineering management or document management. So I see this as a very rich environment with ETL protocol making the links between them. Not one vendor dominated, not one tool dominated. There's a huge distinction between what we're trying to do in GIS and our users are doing with 3D GIS and buildings and what somebody does with, say, a Rivet Revit platform.
Alors justement, vous parlez des produits de concurrents. Autodesk et Bentley Systèmes sont historiquement ont développé des outils au niveau du CAD, de la CAO, puis sont ensuite venus dans le domaine des SIG. Est-ce qu'un jour, il est envisageable qu'ESRI lance son propre outil de CAD?
When we first started developing ArcGIS, there were 3 geospatial platforms, and there still are today, although they're integrating. One was image processing tools, and these were tools that took a remotely sensed image or multispectral image and allowed people to process them and derive information from them. And while that technology continues today, it's increasingly becoming part of GIS. The second one was people that wanted to build intelligent maps or intelligent geographic information sets, and they wanted to analyze them and put them into a database where multiple products could be generated from a single database. An urban GIS, for example, supported applications in public works, but also in planning and also in police. One database, transactionally maintained, many views. The third technology was really CAD, automated drafting tools, which was all about the drawing. It was about creating drawings, managing drawings. And the data models between imagery and GIS and CAD are completely different. A raster model in the case of imagery, smart topological networks in the case of GIS, and display list graphics, which are simply a display. The view is the information, right? So the drawing elements are stored in the database. It's not raw data that's generated into multiple views. It's what you see is what you have in the database. That's CAD. So in the early 80s, when we first introduced ArcInfo, CAD technology like AutoCAD and Intergraph and others, Bentley's technology later, could display much faster because it had a simple data model, but you couldn't do analytics with it. But GIS displayed quite slowly, but it was topological. We could do analytics, you could do map overlay, you could generate multiple products from the same basic data set. So we went to war with the CAD vendors at the time, and many people who wanted simply to do automated drafting of maps selected CAD technology, but people who actually wanted to have a database and do things with it and do transactional, they would go with us. And very gradually, as computers got faster, we began to win the war, because you could do dynamically the generation of maps and visualization from a database and greatly reduce the cost of CAD technology. So today, the CAD vendors, both Bentley and Autodesk, which are both great companies, still have GIS components that tack on to the side of their main business. And they're great companies, as I say, but they're not GIS companies. So we have worked very diligently to try to integrate in CAD with GIS. So at 10.1, for example, an AutoCAD client, an AutoCAD desktop can be a legitimate client to an ArcGIS server. So we can serve into the AutoCAD environment data sets as a drawing. You can edit them there, and AutoCAD becomes an editor for the engineering community, for example, of the GIS space. Our business is not automated drawings, it's not automated engineering. That really belongs to other domains. So our interest is in geography and geographic information. That's our main business.
Et ça a le mérite d'être clair. Alors, avec vos solutions, en fait, un utilisateur peut avoir une vision sur les réseaux, les différents équipements qu'il possède, puis il utilise un autre, pareil à ce que vous venez de dire, un autre outil pour pouvoir les piloter, les superviser à distance. On parle de plus en plus de smart cities, de gestion technique de bâtiments intelligente et à distance. Est-ce qu'un jour, vos outils seront capables de pouvoir gérer peut-être ces smart cities?
Because we moved ArcGIS into a 3D data model with transactions and all of the analytic tools, some users are saying a building is a small geography, and they want to be able to make queries against these things and use the geospatial analytic tools that they did for large-scale geography and a microscale. And they're quite successful at it. So we have a team of people who are building those building data models, which are 3D templates that you can pour an AutoCAD Rivet database into, and it comes alive with GIS operators. It's a small market today, but it's growing rather rapidly, particularly in the public sector, with people who have hundreds of buildings like campuses and universities, or thousands of buildings like government agencies who have buildings scattered all over the place, or things even like fast food restaurant chains who have said, I'm going to take my drawings database and put it into a GIS database so I can ask it spatial questions and do analytics with it. So I'm very encouraged by that. In the area of network management, there have been a few examples of geospatial used for that, but there's also specialized software that is more solution-oriented for that. It may have a life, I'm not really sure at this point. We don't see that as a big market for us at this point.
Et donc pour l'instant, donc, il ne s'agira absolument pas de pouvoir piloter ces engins à distance ou ces équipements à distance.
The ArcGIS server is designed so that there's clients that come with it, and these clients are iPhone clients, Android clients, Windows Mobile, Windows Phone clients, and these clients can do field data capture. So in addition to looking at data, for example, like buildings or facilities, you can also capture information as you're walking around, which does a transactional update on the database. So these aren't independent little device measurement tools like GPS or a Trimble thing. No, they're wired right into a database so that we're transactionally capturing and managing large volumes of data in a server. And at the same time, other people are seeing it. This is a general area of interest to us because we're seeing field workers across the whole city or in a utility company equip their field workers with these devices so that every field worker becomes a sensor who is transactionally updating these big databases that other people are looking at in real time. So people become a kind of sensor network. In our community environments, we have one business partner called, I can't remember their name right now, but they've made a business out of going into cities and providing citizen access and feedback, something we call here in this country 311 reporting, which is citizen reporting of broken windows or graffiti or outage lighting and things like that to the community database. So it's crowdsourcing information. Crowdsourcing is interesting, and for the GIS community it's very interesting. There's crowdsourcing from the social media environments like tweets or Twitter or that sort of thing where we're taking social media feedback and making it overlay on top of other GIS maps. Then there's the concept of crowdsourcing as a methodology for field data collection. Like in the military, every soldier becomes a sensor, or in the community, every citizen is a sensor. Feeding back to the enterprise systems and enterprise decision-making, valuable information that we've never been able to capture before. So generally speaking, in the GIS world, we're moving to a sensor-driven environment. So whether it's GeoRSS feeds or sensor networks like water, weather, hurricanes, vehicle movements, traffic, these are all things that are getting wired up.
Alors, est-ce qu'au-delà de ces nombreux points qui ont déjà été évoqués, nous pouvons évoquer ensemble ce que pourraient être les priorités d'ESRI dans les prochains mois? Finalement, qu'est-ce qu'ESRI a actuellement en magasin?
The future is very bright for ESRI. I mean, I think at this particular point we're going to grow enormously, not so much in the revenue, but in the access to the information that our users are using. And this will be made available through ArcGIS Online, our new cloud offering. Some people have described this as a geospatial content management system, and it leverages all of the investments that our customers have already made in server and desktop tools. It means that they are able to put up in the cloud their content and let other people access it very easily. Okay, somebody's got to pay for the cloud computer, that'll be our user, but access to that free open access for viewing the information that they wish to publish and allow other people to mash up their data, well, that'll be free. And so our engineering has been emphasizing making these free, open viewers, open source viewers, open APIs that people can access this data and make it come alive in their organizations. That's a huge investment. It's actually required hundreds of millions of dollars to build this platform. We've worked closely with both Amazon and Microsoft in crafting it. And a lot of it's going to be in the open web, very similar to the Salesforce.com model for SaaS for geo. But also, it can be implemented in government clouds or on-premise clouds. And a lot of the military, intel kind of organizations, as you would imagine, don't really trust the open cloud yet, so they'll be wanting to deploy it on-premise. This is a big deal for us. I'd say it's going to move our company into a different class of software, beyond simply software products, but software services. To make that platform come alive, we've invested perhaps $50 or $60 million in content development. For example, imagery for the world, or base maps for the world, street maps for the world, that people can overlay their content dynamically on top of and store, persist these intelligent web maps that other people can look at. Our mission is not the same as the consumer mapping tools like Google or Microsoft or Yahoo. It's principally focused on the enterprise user so that they can share their content inside of their organization and make it available for everybody in the enterprise to actually use. This is exciting to me.
Merci beaucoup, Jack Dangermond, de nous avoir reçus ici si longuement à Redlands.
Merci beaucoup.